Good morning and welcome to today's class. Today's class is a continuation of our previous classes on surds. At the last class, we looked at the first objective, which says to differentiate between rational and irrational numbers. And I think we have done justice to that, where we define rational numbers as those numbers that can be expressed as a ratio of two factors, a over b, where b, which is the denominator, is not said to be 0. And we gave you so many examples of numbers that are rational numbers. That includes fraction, whole numbers, squares and square roots, and or whatnot. We also not squares and square roots, but squares are rational numbers, but some square roots too are rational numbers, but some are irrational numbers, and we are going to differentiate that. We also defined irrational numbers as those numbers that cannot be expressed as a ratio of two fractions, and we gave you so many examples as pi, root 2, root 3, root 7, and a few others. In today's class, we shall be looking at surds. What we have learned in the previous class is to aid us, it's just like a revision to aid us in surds. And what are surds? Surds are irrational numbers. By saying irrational numbers, you know what I'm talking about. For example, the square root of 2, that is root 2, is said to be irrational, is said to be a surd, or is an irrational number, which to 11 decimal places will give you 1.41421356238. These are said to be irrational numbers because even while expressed in decimals, they have no end and they have no recurring decimals, just like rational numbers. So we refer to them as irrational numbers, and surds are examples of irrational numbers. The precise value cannot be finally calculated. They are just an approximate values. So surds are examples of irrational numbers. Now let's look at surds. Just like in algebra, we have rules governing it. What are the rules of surds? The rules of surds says that root xy can be expressed as root x times root y, or you can say root x times root y is said to be, can be expressed as root x times y. 2, that root x divided by y is equal to root x divided by root y, which can be expressed as square root of x over y, or root x divided by root y. So you can, when you have it expressed in the as it is in the left hand side, you can simplify it to that which is expressed at the right hand side, or vice versa, whichever way you think can help you simplify your work. 3, the third rule says root x plus root y is not equal to, this sign means is not equal to root x plus root y. Most students make such a mistake by thinking that root x plus y can be simplified to be root x plus y, but it is not. Same with subtraction. Root x minus y is not equal to root x minus root y, provided both x and y are positive. Okay, so these are the 4 basic rules of surds that we will be working with today. So we shall take some examples to help drive home our point. But before that, let's also look at some definitions when it gets to surd. Basic surd. We said root x is said to be in its basic form if x does not have a factor that is a perfect square. That is, root x will only be basic if root x cannot be further broken down into two factors where one of them has an exact square root. Example, we have root 2, root 3, root 5, root 7, root 11, and root 13 are in basic forms. So all these are basic forms of surds because you cannot simplify 2 as a product of two factors where one is a perfect square. So if you look at it, basically, I'll say that surds can be said to be square roots of prime factors because all the digits are prime factors and they are multiples. So these are some of the examples of surds, and they are said to be in their basic form because they cannot be simplified further. Now root 12 is not in its basic form. Why? This is because it can be broken down into root 4 times root 3, which can be simplified using the first law as root 4 times root 3. And we know that root 4 is a rational number because root 4 is 2, but root 3 cannot be broken down. So this gives us root 3. So this is said to be the basic form of root 12, while root 12 can be said to be the simple form of 2 root 3. 2 root 3 is now in its basic form. Let's also look at some definitions as it applies surds. We also have what we refer to as similar surds. Two surds are said to be similar if their irrational parts contain the same numeral. For example, 2 root 3 and 5 root 3 are similar surds because their irrational part contains the same numeral. Where is the irrational part? These are their irrational parts. So you refer to them as similar surds once their irrational parts are the same. So by that, you can collect like terms because they are similar. 3 root 2 is not similar to 2 root 3. This is because their irrational parts are different. This is root 2 and this is root 3. So you cannot refer to them as similar surds, but rather they are not similar. So therefore, you cannot add or subtract them, but you can multiply both of them together. Okay, let's take some examples that we should simplify. Example 1 says, simplify the following. In this example, we shall be applying the rules of surds while simplifying this. Before we continue, you are encouraged to like our videos as well as to subscribe to our channel if you've not done that. While you can also use the comment section to interact with us and as well share the link to your friends and classmates so that they can also benefit from this lesson. Now, A says root into bracket PQ squared. That we should simplify this. Note that this can be written as root P times root Q squared. And this can be simplified to be square root of a square is said to be that number. So the square root of this will cancel the square of this. And this becomes Q times root P, which is equals to Q root P. So this can be simplified to give us this. B, root S squared Y cubed can be simplified to be equal to root X squared times root Y cubed. And this can be further simplified to be root X squared times root y squared times y. Y squared times y is also equal to root y cube. But why am I squaring it? Why am I differentiating this? Because I know that the square root of a square is that number. So I want to also simplify this. That's why I did that. So this becomes root x squared times root y squared times root y. For we know that square root of a square is a number, so square root will cancel this square, same with this, and leaving us with x times y times root y. This becomes xy root y as your answer. C, we are asked to simplify root 75. Root 75 is not a perfect square. So what do? We are going to express 75 as a product of two factors where one is a perfect square. And this can be simplified to be root 25 times 3, because 25 is a perfect square and 3 is not. 3 is said to be a prime factor of 75. So always divide that bigger number by a prime factor, and you may likely get the second factor to be a perfect square. So that's how to simplify this. So this becomes root 25 times root 3, and this is said to be root 25 is said to be 5. Please take note, it's not root 5 but 5 times root 3, because root 3 cannot be simplified, which is said to be in its simple sort form. So 5 times root 3 gives us 5 root 3. D, root 45. Root 45 can also be expressed as a product of two factors where one is a perfect square. And what will that give you? Your guess is as good as mine. That is root 9 times 5. For 9 times 5 is 45. But 9 is a perfect square. Why 5 is what? A prime factor. So this is equal to root 9 times root 5. And root 9 is said to be, square root of 9 is 3 times root 5. This is an irrational number. So this becomes 3 root 5. When you're asked to simplify a surd, which is in its single surd form, you are asked to simplify it to its simple surd form. And this is what you get, 3 root 5. E says root 300. You can as well simplify 300, or you can express 300 as a product of two factors where one is a perfect square, and that gives us root 100 times 3. For 100 times 3 is 300, and this can be simplified further to be root 100 times root 3. And if you simplify, square root of 100 gives you 10 times root 3. This automatically becomes what? 10 root 3. So that brings us to the end of today's class. In today's class, we have learned what surd is all about, as well as the basic rules of surds, as well as we also discussed about basic surds and simple surds, okay, and how to convert from simple surds form to basic surd form. That brings us to the end of today's class. But before we go, let me leave you with this assignment. We are asked to simplify the following by reducing them to their basic forms. So you have about 10 of them to do. That root 50, root 125, 98, and down to root 500. So what you have to do in this case is try to express each of the rational number under the square root sign as a product of two factors where one is a perfect square. And once that is done, you can then find the square root of that perfect square and multiply it by the irrational number. That brings us to the end of today's class. So kindly like our videos if you have not done that, as well as to subscribe to our channel as you watch. Also share the link to your friends and families so that they can also benefit from this project. Thank you for being patient to the end of this class. See you in our next class. Bye.